In a lot of my videos and things that I show, I am using Ubuntu. Now, I know that Ubuntu is probably the go-to for most people who are playing with the things that I like to demonstrate on my channel. However, I can't help but be appreciative of the fact that there are a lot of Windows users out there as well who may be open to actually using Ubuntu, but are not quite sure how to actually go ahead and even get started with that. So, that's kind of what today's video is going to be all about, which is going to be just a very beginner's guide on actually installing Ubuntu alongside an existing Windows installation. So by the end of this video, we will have a system that can dual boot either Windows 11 or Ubuntu, and we will have a simple environment set up in Ubuntu as well that should allow us to actually go ahead and run some of the examples we see on my or others' channels, specifically relating to kind of AI or machine learning tasks. Now, prerequisites and disclaimers. To best follow along with today's video, you should have an Nvidia graphics card, likely a 3000 series or newer, and also some familiarity with the BIOS would be helpful, as some of the things we're going to do will require actually going into our system's BIOS. And while I will show step by step how to actually do that, the problem is many different manufacturers of motherboards have different keys or graphical layouts to actually get into the BIOS and then navigate around there. So fundamentally, the steps that need to be taken will be the exact same. However, in practice, your BIOS may look different and you may actually have to press a different key to get into yours depending on motherboard manufacturer. So with that out of the way, I will just put the system information of what I'm going to be using today down in the screen, and we will basically go ahead and get started by just actually downloading Ubuntu first and foremost, and then go into partitioning our drive, installing Ubuntu, and then ultimately being able to use it to run some machine learning fun stuff. So let's get into it. To begin, we are just going to go to ubuntu.com/download, and we're going to go to desktop from the option here to choose the OS you need. Now, we will be met with the option to just go and download the latest version, which is Ubuntu 24.04.1 LTS. And LTS is a designation given to kind of the Ubuntu operating system and many other kind of things. Unity has LTS as well, but the designation means that it will be supported long-term with updates. So if you want to stick with something, getting an LTS version is the one to go with, because they have extended software support and security support and things of that sort. So we can see that pretty much I reiterated what was said right here, where LTS stands for long-term support, which means 5 years of free security and maintenance updates. Now, in all of my demonstrations and pretty much any of my use of Ubuntu to date, I have only been using Ubuntu 2022.04 LTS, and being that I'll still get a good year or two out of that, and lots of potential compatibility issues will have been ironed out on that older version, I am actually going to be using that for the guide that we are going to embark upon right now. With that said, we need to actually go ahead and manually navigate to the page where we can get Ubuntu 2022.04 LTS. To do that, it is quite simple. We just go here to check out our alternative downloads. And from this page, we can scroll down. We don't want to do the BitTorrent. We don't want to click on other images and mirrors, but we want to find past releases and other flavors. And we want to look for Jammy Jellyfish, which is the name of Ubuntu 2022.04. And we'll click on this one. We can see this is the LTS version. And that brings us to a page where we can actually go ahead and easily download the desktop image. So we are going to do this. Now, it might be confusing because you'll be like, oh, well, I don't have an AMD processor, so this makes me confused. You can just kind of ignore that. Although it may seem kind of confusing, this will work with Intel processors or AMD processors. It won't really matter. It's just kind of confusing when it says that for someone who may not be familiar with Ubuntu and some of its intricacies, if you will. So we are basically going to go ahead and download this by just clicking on this, which will go ahead and download it. You can see it is about 4.5 gigabytes, so it won't take too long depending on network speed. While this is downloading, we can actually go ahead and begin the next step that we are going to embark on, which is actually to download a program onto our machine that will allow us to flash this image onto a USB drive in order to actually be able to use that USB drive as an installer for Ubuntu. Now, if I quickly make a new tab here and then search immediately so we can get rid of this disgusting mess of news stories here, I will just look up Balena Etcher, which is a program that does this. It is free and open source, and really it is quite simple and nice to use. So all we're going to do is go ahead and from the website etcher.balena.io, we are going to download it. I use this personally quite often, and I will vouch for it as being a nice and kind of aesthetically pleasing program. So as we are on Windows here, we are going to go ahead and download the Windows installer, and this will likely complete far quicker than the Ubuntu disk image will. And well, maybe I spoke too soon. That download speed is abysmal. But once that's done, we'll go ahead and set it up and get our USB flashed, which will lead us into the next step of actually partitioning our drive so that we can have Windows 11 and Ubuntu side by side on the same machine. We can now see that both downloads have completed. So for the next step, we can go ahead and close the browser, as we are going to go ahead and now install Balena Etcher so that we can actually create a bootable USB of Ubuntu. So from my downloads folder, we will find the Balena Etcher setup installer. If we click that, user account control will probably ask us if we want to run it. Oh, okay, well it didn't. So basically it just kind of opened it here, and it seems like it's installed itself. Okay, well, that was kind of a little confusing, but basically it seems like clicking this actually installed it and set it up, and we can see there is a desktop shortcut now. So to open Balena Etcher, you just click the desktop shortcut that is newly appeared, and we can go ahead and then actually begin with flashing our flash drive. So make sure you have a 16 gig or 32 gig flash drive will be fine. I suppose you could get away with 8 as well. And basically just plug it into your computer. And once you have done that, you are going to click the flash from file here. And from there, we are going to navigate to the downloads folder where we have our Ubuntu 2022.04 disk image. So we select this, click open, and following that, it will kind of just show it there. It will be concatenated because it's too long to display in this text field. However, once we've done that, we can click select target here, which is essentially just telling Balena Etcher where we want to actually install this image onto, which for us is going to be the flash drive that we will have plugged into our computer. And of course, make sure the flash drive does not have anything sensitive on it or anything like that, because this will kind of wipe it and then go ahead and install the image. Now we select, and following that, we are going to click flash. If you are using, okay, yes, we need to click yes now here. If you are using a large flash drive, like maybe 64 gigs or above, maybe 128, Balena may prompt you and say, hey, I want to check that this isn't a system volume that you're flashing. It's just checking to make sure you're not accidentally wiping your hard drive, because it assumes something that large could perhaps be a hard drive. So I just kind of want to point that out. It is quite self-explanatory if you do run into that, but just so you don't get caught off guard, I wanted to mention that. And we can see this will take a little bit of time. So first it will flash and then it will verify, which will take maybe 15 minutes total or something like that. And then we can move on to our next step, which will actually be partitioning the drive so that we have space for Ubuntu as well as Windows. So I think I said that this would verify. I meant validating. As we can see, it's just finished up doing right here. So basically, we are now all set once it has finished and says flash completed. And really, you don't need to go eject your disk or anything like that. Okay, maybe you should, but normally I just pull the USB flash drive out at this point and it doesn't seem to have an issue. Our next step involves partitioning the hard drive to allow space for Ubuntu and the existing Windows 11 install. Before we get into this, I want to make note that it is very important to have a backup of your data when doing anything like this, specifically regarding the drive or its formatting or partitions or anything like that. It is relatively safe what we're going to be doing here, but you don't want to be that 1 in a million chance that something goes wrong and you don't have your data backed up. The only other thing I want to kind of preface this with is that a lot of the AI or machine learning repositories that you may end up playing with likely require pretty large model file downloads. So when we partition the drive, we are actually going to have the option to determine how much size we want to allocate for the Ubuntu operating system. And really, if you just want to play with it and get a feel for it, you can go small, like 30, 40 gigs, even 20. But if you actually want this to be usable and be able to accommodate large files, I would really recommend having like 200 gigs free space at minimum to actually allow for Ubuntu. That is kind of just an on-the-fly estimate, but it does fill up quickly with some of these models and things like that. With that out of the way, to begin, we are simply going to navigate down to the taskbar right here and right-click the Windows icon. From the menu that shows up, our interest is in this disk management section right here. So we are just going to click on this, which will open up the disk management window. Now, to put it kind of simply, you can just think of this as kind of like a graphical layout of our actual hard drive and its partitions and space and free space and things like that. We don't need to get too technical with this, but from here we are actually going to be able to partition this drive so that Windows and Ubuntu can coexist and basically share the drive space in an eloquent and compatible manner. We can see here on disk 0, which is the main SSD in this computer, which is a terabyte of total space. We can see that our C drive, which you may be familiar with if you've used Windows, is taking up the entirety of the space pretty much. There are some things right here for recovery partitions and things like that, but we can kind of just ignore that for the scope of this video. However, we will see that this drive has 96% free. So in my case, I have 910 gigabytes of free space. Yours will likely be less, as this is kind of a fresh install on an operating system on this. So basically, I don't have anything installed on this computer, so most of the space is free. But the important thing is to note how much free space you have, because that will kind of guide you in choosing how large of a partition you want to make for the Ubuntu install. Now, in order to actually partition this, it is actually quite simple. We're simply going to, in my case where I have one SSD, which is right here, we are going to click on the main kind of block right here, if you will. And once we have it selected, we will see that it has these stripes and things like that to actually designate that that is what our cursor has selected. We will right click it and click on shrink volume. Now, this is basically going to allow us to make the C drive take up less space so that we have free space left over to actually install Ubuntu. Very non-technical way to put it, but that is kind of the way to go. Now, it is kind of a pain here because it's doing everything in megabytes, so it may seem slightly confusing at first, but we can just see that 932 gigabytes of right here. Okay, that's what it's allowing me to shrink it maximum. Basically, this says 932,155. This just means 932 gigabytes. So it may be a little confusing at first glance, but that's just kind of how it shows it, which is in megabytes. Now, I would like to have, I'll say 200 gigabytes for the Ubuntu partition. So basically, the amount of space that I want to shrink is actually going to be equal to the amount of space that I want to allocate for Ubuntu, which in my case is 200 gigabytes, which in the megabyte formatting here would simply be 200,000. And then we can see that the size of my drive after shrinking it, which doesn't actually mean the physical size is going to change. It just means that the size of the C partition will change to 200 gigabytes less. And once we've done that, we will go ahead and click shrink. And it should not take too long at all, but we can now see that the C drive has shrunk. And next to it, there is now a 200 gigabyte unallocated space, which is what we are going to actually go ahead and install Ubuntu on. So now that we've done this, we are pretty much done with Windows for the purpose and scope of this video. And we can basically go ahead and actually reboot our system, which will allow us to go ahead and initiate the Ubuntu install. Our next step can perhaps be daunting to some, as it's perhaps not an area they've really ever needed to play with their computer. And for this, we are actually going to need to go into the BIOS of the system and manually select the USB flash drive as our boot device. That is really just going to allow it to run the Ubuntu installer, which will then actually go ahead and place Ubuntu onto the partition we made on the hard drive. Now, in order to do this, we must go into the BIOS, which will require basically spam clicking a key that is dependent upon the manufacturer of your motherboard. Common keys to get into the BIOS are delete, F12, maybe F2 or something like that. But really, this will be specific to your system. So for mine, which is an MSI motherboard, I am going to need to spam click the delete key to actually get into BIOS. To give kind of a little bit of pertinent information, for the scope of this video, we can think of the BIOS as just a lower level way to communicate and set some specific things for our system. It's kind of closer to interacting with the hardware than using an operating system is. I hope that kind of makes some sense, but hopefully it will more as we actually go and get into this. So what I'm actually going to do to make sure that I have the most time to actually spam click that key to get into the BIOS is first actually just completely shut down the computer instead of restart it. And once it has turned off, I'm just going to turn it back on via the power button. And as soon as you press that power button, you're going to want to just spam click the key on the keyboard. Now for me, that is the delete key, which on this small little keyboard is right here in the corner. So I will just show that on camera as well. I am now clicking the power button, and as I've done that, I am just going to kind of spam click this delete key. And then once we see a very different looking screen, which will be the BIOS for our system, we can then stop clicking this key. And that's what we're met with right here. So, like I said, my motherboard is an MSI variant. Yours may be something different and therefore may need a different key. But functionally, it will be the same, where you find out what key you need to press to get into BIOS, and then you just kind of spam click that key until your BIOS comes up once you restart the computer. Now, I do need to just quickly make sure that my recorder software did actually get this, so we do see the BIOS, and once I check that, we're good to boot from the USB and install Ubuntu. So we can see that we are now in the computer's BIOS, and unfortunately this is kind of one of the steps where your specific hardware could perhaps have this looking quite different. So really what I'm going to show here is functionally identical to what you will have to do as well. However, in practice it may differ from a graphical standpoint depending on your motherboard manufacturer. Now, this is an MSI Z690A Pro motherboard, and this is what my BIOS looks like. But from within here, we are basically going to select the USB drive as our boot option, restart the computer, therefore booting from the flash drive, which will lead us into the Ubuntu installer. Now, I personally don't actually know how to navigate my way around here unless I'm in the advanced mode, so I'm just going to change into that. But once I have done that, really what we're going to do is just find a well, not that. We're going to find a location in our BIOS, which again is very dependent on your specific motherboard and hardware manufacturer, that we can actually override the boot settings with to choose the flash drive. For me and in my BIOS, I can simply go to save and exit. And if you have an MSI board, this may be quite applicable to you, hopefully, but I can't guarantee that. And as I click that, we are going to navigate down here till we see the last option, which is boot override. And from there, we can select the USB disk, which of course is what we flashed Ubuntu on using Balena Etcher. And once we do this, it will override the default booting into the hard drive behavior that we are used to seeing, and it will go ahead and give us some cool options. So I am going to press enter here, which will go ahead and restart the system, but with that boot override. We can now see that we are met with a cool little, by the way, that didn't restart the system, it just selected the boot override, so I just to continuity make sure I didn't get that wrong. We can see from this menu right here that we have a few different options. For us and what we want to do, we are just going to stick with the first one, which is try or install Ubuntu. And one of the cool things about Ubuntu is that you could actually use Ubuntu on the operating system entirely from this USB without needing to actually install anything on your machine, which is quite cool. However, for what we do, we totally need it installed on the system because we need storage space and more performant behavior and things like that. But it is just kind of cool that you can make a flash drive of Ubuntu, plug it into a random machine, and then actually use the operating system without needing to install it. However, we are, of course, going to go ahead and install it, which once things show up on screen, we will go ahead and do. So we are met with a nice kind of wind chime sounding noise. And from that, we are going to click the right option here, which is to install Ubuntu. From there, we just select our keyboard layout, which for me is English US. Now, here's where we have some choices we can make. If you want a normal installation, think of that as more like a full-fledged operating system with a bunch of additional software pre-installed, like web browsing software, some games, some document reading software, and things like that. Basically what it says right here, which is web browser, utilities, office software, games, and media players. Personally, when I install Ubuntu, I am not really interested in using it as a full operating system, so I don't need much of these. I just kind of want the bare minimum installation because I'm going to customize it to my liking. So I am going to opt for the minimal installation, which as we can see is just a web browser and basic utilities. If you would like to have some office software, which I think is OpenOffice, or I don't quite recall, but it's open source office software, which really isn't bad. You can choose normal installation, but I'm going to go with minimal installation. You can also select download updates while installing Ubuntu. I am actually going to go ahead and do that as well. And following that, we are basically just not going to press anything. I am not going to click install third-party software for graphics and Wi-Fi hardware, as when having like the Nvidia ecosystem and needing to set it up, it kind of just gets easier sometimes to manually do it yourself. And you also learn more by doing that. So I'm doing minimal installation and download updates while installing Ubuntu. From there, we are going to click continue. So as we can see right here, Ubuntu and the Ubuntu installer have recognized that this computer currently has Windows Boot Manager on it, which basically means, hey, I see this computer has Windows on it as well. What would you like to do? We do not want to do this one, which has warning, which is erase disk and install Ubuntu, because that will destroy our Windows partition and all of our files. However, fortunately, it is pre-selected to install Ubuntu alongside Windows Boot Manager, which, to put it in a more visually explainable way, is basically installing Ubuntu on that new block of 200 gigabytes of free space that we made in the disk management section in Windows. So if we ensure that this is correctly set, as it is right here, we are simply going to go install now, and it will go ahead and, well, there will still be a couple steps we need to take, but this will make sure that we are going to correctly do this and keep Windows. And it will give us some warning here, which may be just kind of too verbose to actually understand, but as long as the correct option here is selected, we can click continue. From there, it will ask us some locality information. I'm not in New York, but it's close enough that that will be the correct time zone, so I can click continue. And then we are going to simply just do a username or computer name or things that you're familiar with, because these are somewhat kind of like OS agnostic actions. And then a password. And you can choose whether or not you want to log in automatically or require the password to log in. I generally just have it auto login, but that's a personal decision. And once that's done, we will click continue, and it will go ahead and actually install Ubuntu onto the free space partition. Generally does not take very long at all, but we'll just kind of let this complete and then touch back when it's done. And once the installation completes, we will see right here that it just prompts us to restart, which when we do, the computer will reboot and show us a screen asking us to remove the USB that had the Ubuntu installer on it and then press enter or something like that. Okay, good. I was right. So we are simply going to just, good God. All right, remove the USB drive, and then once we've done that, we will press enter, which will go ahead and allow us to progress further into our installation process. So when we removed this USB installation medium and press enter, what should have happened was it should have just then rebooted into Ubuntu, where we could basically go in and play with it for the first time. Unfortunately, and I am not sure if this is just because I'm using the enterprise ISO with the 90-day trial or something else, it did not work, and basically it just booted back into Windows. Now I am going to leave this in the video for anyone that may also face this issue, and we'll basically work through it together, because I'm not 100% sure on the steps needed to be taken to actually remedy this and have a proper dual boot system. So first and foremost, it has basically rebooted into Windows now, following removing this USB drive and pressing enter. I'm going to, from here, just reboot the system. And as soon as I do that, once the screen goes blank, I am going to spam the key once more to actually get into the BIOS, which on my MSI motherboard is the delete key. And once in the BIOS, from the settings section here, and again, this is very platform specific, but this is kind of just a general way to do things, I am going to navigate to the same menu where we actually went to select the boot override, which for me is under save and exit, and then down here in boot override. We can, however, now see that there is an Ubuntu partition that is identified or registered here, which is good. So we are going to just select this manually in the boot override settings and then allow Ubuntu to finish its kind of installation and first boot process in the hopes that this will actually go ahead and remedy our issue of this automatically booting into Windows, which should not be happening. So I will press enter and then we will see what we should have seen, which is Ubuntu. And basically, so this screen is going to go away in 4 seconds, which is why I have to rush through. So just press enter right here when you get the option there for Ubuntu. But realistically, what should happen is when we start up our machine, we see that screen there, and it either allows us to select booting into Ubuntu or Windows Boot Manager, which is our installation of Windows 11. So we can now see that we are back where we should have been when we pressed enter after removing the installation USB flash drive, and Ubuntu is going to set itself up and we will be met with the desktop for the first time. The first and foremost important thing I need to do is simply for the video purposes here. So I'm going to change the display setting to 1920 by 1080 so that it is easier for you folks watching at home to actually see what is on my screen. And now that that's done, we can go through the initial kind of setup options for Ubuntu. I'm personally going to just skip pretty much all of this. Yep, skip. Prefer not to send system info. I don't want location services. And then basically it says, okay, you're all set, you're ready to go. You can use software to install apps like these, so just think of software as like the actual app store for Ubuntu. So it will ask us if we want to update. I'm just going to close all of this for now. And what I am actually going to do, because I'm sure this will be kind of the most pressing question by many at home who have just done this, is show how to get back into Windows or Ubuntu. So I'm going to just shut this system down. And then once it has turned off, I am going to just turn it back on using the power button. Unfortunately, my machine is not properly behaving in terms of giving us the option to select either operating system when it first starts up. So I am going to go back into the BIOS by spam clicking the key for my motherboard, which is delete, which at this point you've probably memorized as well. And again, very platform specific right here, but this is kind of a general functional overview of what you will need to do as well, assuming you are facing this issue, which you may not, because when I installed Ubuntu side by side with Windows 11 on my Acer laptop, it was totally fine and worked perfectly out of the box. I didn't need to mess with any of this. So from my BIOS, I am simply going to go into the boot section, and all the way at the bottom where we have UEFI hard disk drive BBS priorities, I am going to press enter, and from here we can see that we have boot option number 1, which is Windows Boot Manager, and boot option number 2, which is Ubuntu. Now I am actually going to want to switch this so that Ubuntu is boot option number 1, because that will actually bring us to the screen where we can select which operating system we want to choose to use every time we start up the computer. And in order to do that, I am just going to use the plus sign, or hit plus or minus. Your BIOS might be different, but either one of those will kind of change the order of these. And now we can see that Ubuntu is selected as boot option number 1. So I'm basically just going to exit and go into save and exit and save changes and reboot. And assuming that everything has been correctly set up now, we will just say yes, as we want that configuration to persist. We should now be met with that old kind of terminal looking retro style screen where we can select to go into either Ubuntu or Windows Boot Manager. And fortunately we can. So if we did want to get back into Windows now, we could just scroll down and select Windows Boot Manager and press enter, and this will boot into the regular Windows 11 operating system that we have on our system. And I'll just let it boot up now so we can see that everything works and we're all set still with Windows and we haven't made any disastrous modifications to the system. And I will just log in for good measure. And we can see that our Windows environment and operating system still exists and everything is safe. So once we've done this and verified that this is still good, we are basically just going to go ahead and actually shut this down or reboot the system and go back into Ubuntu. Basically, every time you start up the system, you will be met with that screen to actually select the operating system. That's kind of just a function of this. There may be other ways to actually do this, but this is kind of just how it works for dual booting in a lot of scenarios. So we can see that if we press enter on Ubuntu there, we will then go into the newly installed Ubuntu operating system on our machine. And once we're met with the desktop here, we can pat ourselves on the back because we now have a proper setup dual boot machine of Windows 11 and Ubuntu 2022.04, which is pretty cool. Now that we have Ubuntu up and running, there are a numerous amount of directions that we could take this. However, in keeping in the scope of this video, which is basically about getting this to a point where we can actually go ahead and run some of the cool repositories that we find on GitHub relating to AI and machine learning and take advantage of the Nvidia graphics cards to do so, we are going to basically set this up in that scope. There are vast amounts of resources out there about using Ubuntu and customizing it to your liking and things like that. But for this video, we are pretty much going to strictly adhere to just setting up our graphics drivers, setting up the Nvidia Cuda toolkit, setting up Conda, and basically then we'll just test run a repository to make sure that everything works. Now, I will just quickly talk about Ubuntu since it is perhaps new to us. It is really just kind of like an operating system like Windows or Mac. It has a desktop environment, it has a graphical file browser, it has a settings menu, and pretty much everything you would find on like a more traditionally used OS, I suppose you could say. There is one thing that I would like to kind of make note of, and that is something that could perhaps make it a bit harder to actually get used to Ubuntu, and that is just kind of the positioning of the dock on the left side of the screen here. So if you actually do want to change things around here, in the top right of the menu bar, you can click right here and go into the settings pane, which basically will just open the system settings pane. If you're more familiar with Mac OS, this will actually look quite familiar, as the newer variants of Mac OS actually have a very similar settings application to this. But you can go into the appearance tab here, and you can see that the system does actually have a dark mode option. In addition to that, you can change the accent color for the UI elements if you would like to. However, I am just going to keep everything default for now, as it may help to visually see the similarities between what I show here and what you see on your own machine. In addition to that, the thing that I really wanted to bring this up for is the dock. So if the dock is kind of in an odd spot for you, perhaps to make it a bit easier and simpler to actually transition over from using Windows, in the dock section here under the appearance tab in the settings pane, we can actually change the position of the dock on the screen. So we can put it on the bottom to make it more similar perhaps to the Windows Task Manager and things like that. So, excuse me as I am losing my voice, but this really is just kind of simple, and you can actually make it auto hide so that if a window overlaps with it, it will go away and things like that. And the only other thing that I want to kind of mention real quick is sometimes if you drag a window up like that, it will try to auto expand it, which personally I find can be a bit frustrating. So if you do want to disable that behavior, first I am just going to put the dock back on the left side of the screen. But to disable this kind of expansion behavior, we can go into multitasking here and deactivate the active screen edges, which will kind of alleviate that from being a concern of ours. The next thing we're going to do is really jump into the terminal. When starting out in Linux or Ubuntu or anything that requires the command line to be used perhaps more often than what you would on Windows or Mac, it can seem like a kind of evil at the beginning, but it is a sort of necessary evil, as a lot of the cool things we are going to want to run on GitHub and things like that do require us to use the command line to either get them set up or interact with them or etc. really. So we are basically going to go ahead and actually open the terminal application on our Ubuntu installation. Now, there are two ways to do this. The first is perhaps a bit more cumbersome, but it is graphical in nature, and that is to just navigate down here to the applications kind of button, I suppose you could say here. And if we click on that, we will see that there are not too many here, as we did opt for a minimal installation, which only included the kind of bare minimum default applications. But we do see right here that terminal is an option. So one way to open terminal is basically from this applications pane and then clicking terminal, which will go ahead and open this perhaps intimidating looking command line piece right here. However, because we can kind of use some keyboard shortcuts to make things go a bit quicker, there is another way to actually open terminal that is much faster and will make you feel cooler as you do, in my opinion. And that is to just press Control Alt and T at the same time, which will basically act as a keyboard shortcut to open the terminal application. Now we can see that this is pretty much our first look at the terminal, and something I am going to do real quick that you most likely will not need to do unless you want to is actually change the text size of the terminal, and I do want to do that just so that it is easier for folks at home to actually read whatever's being typed in there. So fortunately, I can just do custom font, and then I will change the size perhaps to like 16. Oh, I was hoping I would guess it right where I clicked it, but I did not. Okay, so there we are at 16, and we can see the terminal window has become quite large. Now, that we are in here is no coincidence, because this is where we need to actually go ahead and begin to set up our system. The first thing we are going to do, you can kind of think of as akin to running Windows Update. While not kind of the exact same thing in practice, it is a similar enough metaphor that it will kind of cover what we are going to do now, which is to just kind of update the system packages and things like that. So imagine that this Ubuntu installation has a catalog of different features and pieces of software that it can kind of use. What we're going to do here is first check that catalog to see what can be updated, and then actually go ahead and then update it. So I'll move the terminal center. I'm used to having it over there when I film. But to do that, we are just going to type apt and then update. Now, something you may have seen is that, okay, well, I've seen you type in pip, like what is apt and things like that. To put it very simply, apt is kind of like the Ubuntu system kind of package manager. So things that are installed or done through apt will persist kind of through the system. Whereas pip is Python specific, so that is more intended, well, not more intended, that is intended for Python packages. That may not make perfect sense right now, but as the video progresses, we will kind of see some of the differentiating of those two in action. But I did just kind of want to bring that up for now, just to kind of keep that in the back of your mind. So as I type apt update right here and press enter, we are going to actually see that we get our first perhaps kind of scary looking error. And what this means here is that we did not run this command using sudo, which we can actually see referenced right here. And basically, to put it simply and perhaps in a way that is more relatable, when you do something in Windows, user account control very often nags you to say, hey, this wants to change your system. Do you want to allow it to do that? And then you click yes, and then it proceeds with the action. Think of typing sudo as sort of Linux's user account control setting, where you append sudo to the beginning of a command that could perhaps change things on the system, that it just wants to make sure you're certain you want to do that. So in our case, where we want to kind of just see what packages we can go ahead and update using apt, we can re-enter the command, but this time appending sudo in front of it, or sudo, however you want to pronounce it. It stands for super user do, which I think comes from a time before my own time. But we can type sudo and then apt update, and we will see then that we are prompted for our user password, being that this requires kind of elevated permissions to go ahead and function. And once we press enter, we will basically see, okay, there are 55 packages that can be upgraded. If you would like to see what they are, you could run apt list -- upgradable. And if we are to do this right here, we will see that we don't need to append sudo to this, because certain commands require elevated permission while certain commands don't. There's probably more of an explanation for that, but just surface level, I want to just bring that up so it doesn't seem confusing if sometimes I do write sudo and sometimes I don't write sudo. So we can see these are all the packages that can be updated out of that list of 55. So the next thing we are going to do is actually go ahead and kind of update these packages and just kind of think of this as running our Windows update for this Ubuntu system instead. So I am going to type sudo apt upgrade, which will go ahead and actually upgrade these packages. And it will ask us if we do want to do this, which we can either type Y for yes or N for no. And whichever one we pick, we type it and then press enter. And once that's done, we basically have performed a sort of like Windows update to our operating system here. Now, really, the next thing we're going to do, we can jump right into, and I know you're going to love it, but we stay in the terminal for this part as well. So basically, our next step is actually to install our graphics drivers, which means that we need to have drivers so that Linux can communicate with our Nvidia graphics card. This specific system has 2 of them. However, it does not make a difference in practice for what we are actually going to do in order to get the drivers installed. I think the best way to kind of show this is show you something that I routinely type in my videos, which is Nvidia SMI, which you can kind of think of as like a control status panel for the actual graphics cards. If I type this right now and press enter, we are going to see that it is not found, but it can be installed with, and then it gives us a whole bunch of potential options that we could run to install our graphics drivers. Now, this is something that, again, kind of like when going into the BIOS, whatever that specific key for your motherboard was, this can kind of depend on your system setups and things like that. So what I'm going to show here is the process that works best for me and my system. Now, I have done this on systems with Nvidia 3000 series and 4000 series cards, and this has always worked properly for me. So this is kind of how I do it. I just kind of want to put that out there. So we are going to open the browser first and foremost. And from there, when we have it open, we are just going to type Ubuntu Nvidia drivers. And we will see the first result is this Nvidia drivers installation page from Ubuntu's website, where basically we can scroll down and see a bunch of instructions on how to actually go ahead and install our graphics drivers for our Nvidia cards. There are a bunch of different options here. So kind of when I was referring to that I'm going to show what best suits my use case, that's what I mean is which one of these I'm going to pick. Now, we can see that if we were to actually just kind of go ahead and run through this as it is mentioned here, we can. So if you do want to copy paste something into the terminal, you would just copy it normally with the Control-C from wherever it was going, assuming you're not copying from the terminal. So Control-C right here. And then if I were to want to paste this in the terminal, I would have to actually type Control-Shift-V, which would then paste it. If I just typed Control-V, it would not work. So the terminal has slightly different interactivity for copy pasting and things like that. Something just to keep note of, and perhaps just kind of doing the traditional right-click paste while you get used to this may be acceptable as well. So if we run this, we will see no such file or directory, which is basically just saying, hey, you don't have an Nvidia driver installed on your system. So what we're going to do now is basically go ahead and install an Nvidia driver. Now, I have had the best luck with this Nvidia driver 550. I have tried the 535 and some others, and it has given me problems on multiple different systems. So I just find this one works well for me, so that is what I'm going to show installing. Again, it may be platform specific depending on your specific kind of system makeup, but I think ideally this should work. So in order to install the driver, we are just going to scroll down here to the sample for installing the 535 driver. We are going to copy, paste it into the terminal here. However, instead of 535, we are going to type 550, just like that. And we are going to then press enter. And this will go ahead and actually install the Ubuntu driver for our Nvidia graphics card. And it will be the 550 driver, which, like I said, probably 10 times now I've had the best of luck with. So it may take a little bit of time, and we just kind of wait for this to conclude. Now, while this is being installed, I think it's probably a reasonable time to bring up that sometimes graphics drivers and Nvidia on Ubuntu are going to just have issues. It is prudent to probably be aware that some folks have problems when their systems have Secure Boot enabled, which is an option in the BIOS, which kind of just helps make sure that like actual like lower level software you run on the system, like drivers, are properly signed, meaning like they're safe and not malware or things like that. So it is sometimes an issue where basically Secure Boot can cause problems with specific drivers on Linux. Just something to be aware of. The way this is right now, we likely won't have to deal with any of that, but I do just kind of want to mention that. And to be honest with you, if you just look up Secure Boot Nvidia Ubuntu, you're probably going to see a very large list of kind of individuals who are encountering those issues. So if that is something you have a problem with, there is a lot of documentation out there and troubleshooting steps to hopefully kind of get you around that. But once the driver is installed, we can basically see right here, it says done. And the next step is just to actually restart the system. And we will see that if everything is set up according to the previous half of this video, we will be able to select Ubuntu when we first restart the system. And once we do that, we may see some kind of like concerning text appear on the screen that makes us think something may have gone wrong. If that does happen, just kind of give it like 5 or 10 seconds and it hopefully will kind of then boot up normally and everything will be fine. Fortunately, that didn't happen for me, but sometimes it does. So I just kind of want to mention that just in case. I mean, it's funny because the last time I did this in this exact same setup, it did that where it had some weird message that kept like showing up and then 10 seconds later it went away and it booted. So again, drivers and this stuff can be a little finicky. However, I can tell that this has taken effect because you may notice as well the screen resolution has changed back to the default for the monitor I'm using. So I'm just going to start by changing that back. So we can then once again go into terminal by typing Control-Alt-T and then typing Nvidia SMI to see if our graphics cards are then recognized, or singular graphics card. I mean, one thing about the terminal that may be cool to know is that you can actually use the arrow keys to cycle through previously entered commands. So I have previously entered Nvidia SMI. So if I wanted to just find it using kind of the memory of the command line, if you will, non-scientific term, but I can just kind of hit the up arrow key until I find the previously entered command of Nvidia SMI. And once I have found that, I can press enter. And fortunately, we can see right here that we did not get an error message, but we are met with a perhaps familiar kind of look of the Nvidia SMI status panel, I suppose. There's probably some specific name for this that isn't status panel, but for my purpose, that's what I call it. So basically, this shows us graphics card temperature, power utilization, VRAM utilization, actual like graphical computation utilization, and a whole bunch of other things like that. However, the thing with this is when you run it, just like Nvidia SMI, it basically just takes a snapshot of all of these metrics when you run it. They don't actually get updated on the fly, which can perhaps cause an issue when you need to be mindful of your temps or power usage or whatever. So there are two things we can do. The first is really quite simple, where we can basically type watch-n1 and then Nvidia SMI, which will basically set this to refresh every second, as kind of denoted by the fact that there is a clock here that is now ticking every second. And my graphics cards are not really doing anything right now, so we won't see too much change in any of these actual metrics here. But that is kind of one way we can do this. However, something else that I think is kind of a bit cooler is this program called nvtop, where it graphically shows you a lot of these things and it looks cool, and I've actually been using it in a lot of my recent videos. So we are going to go ahead and just actually install that right now, so we have a different way to kind of monitor our cards. So I am going to press X here, and it will actually ask us if we want to close this terminal, because even something as simple as just running that watch every 1 second like this reads it as there is a process going on in this terminal, even if it's just updating this every 1 second. So it wants to make sure that we are going to want to exit that process. And since we are, we will just hit close terminal. And basically, we're going to hop right back into the terminal. Now, I don't by memory remember the specific command to install nvtop, but if I just type it into the terminal, it will say like it's not installed, but this is how you can install it. That won't always work, but for something like this, fortunately it does. So we can see that I can do sudo apt install nvtop. And if we kind of remember, we touched upon briefly that apt means it's kind of like a Ubuntu system-wide package that we're installing. So again, don't get too caught up on that. I just want to make sure that we understand there's a distinction between apt and something like pip. So if I run that right now, this will go ahead and ask me for my password, as we are running it with sudo for elevated privileges. And once it's installed, which is quite quick, we can then type nvtop once more, and we will see kind of a cool graphical display of our video cards and things like that. We get like a cool kind of like sine wave looking chart here of utilization and things of that sort. And you may notice in my videos, I usually just kind of have this up in the top corner like that. So just another way to kind of monitor our cards and see what's going on with them and keep an eye on them. And now, yeah, it's pretty cool. So with that set up, we do actually have our graphics drivers all set, and the system can see the cards, and everything is pretty nice so far. Now that our graphics drivers are all set up, we are basically going to move on to the next piece of the puzzle, which is actually to install the Nvidia Cuda toolkit. Now, for simplicity's sake and within the scope of this video, we can just think of the Cuda toolkit as a sort of framework and library that allows our graphics cards to better be utilized for some of the machine learning things that we will be doing on this system. Now, it is far more than that, but just think of it as something that allows these graphics cards to really shine for machine learning tasks. And it is part of the reason why Nvidia is very highly regarded in terms of running all of these examples and things like that, because their software is very kind of heavily utilized by a lot of folks who make the repositories and things like that we will test. So verbose, but Cuda toolkit essentially will allow us to really utilize these GPUs for machine learning tasks and things like that where they shine. And it is a requirement pretty much for most of the things we will want to run on here, assuming like you want to run stuff like I do on my channel, I guess you could say. So, surprise, surprise. In order to install Cuda toolkit, we do need to first go into the terminal, because we actually need to see the Cuda version that our cards are using right now. That may sound confusing, but just bear with me and we'll walk through it step by step, and it will make a little sense. So for this, we can just type Nvidia SMI once more. And when this somewhat familiar now kind of screen opens, we will see a few things. One of those is right here, which is our driver version, which we can see 550.120. If you recall, we installed the 550 driver version. However, on the side here, we can see that there is also a Cuda version, which in this case is 12.4. Now, this is important to note because we are actually going to want to install the Nvidia Cuda toolkit of the same version of what is listed here in Nvidia SMI. So once we have identified our Cuda toolkit, let's just first take a look at how we will actually be able to tell when the Cuda toolkit is installed on our system. And that is through typing nvcc in the terminal. So just like that, if I were to type nvcc version, which is basically asking the system, hey, is this installed and what version is it? And we will see, okay, it's not found, but it can be installed through this. Now, I generally never just do this because it's sometimes easier to manually download and install it and set it up to ensure that the correct version is installed. And fortunately, it is actually quite simple to go ahead and actually do all that, which we will basically run through right now. So we jump back into the browser, and basically a lot of this stuff I just Googled to get to the correct URL for it. I don't know if that's good or not, but that's kind of just what I've gotten used to doing. I am going to type Cuda toolkit, and if everything is all right on Google's end, the first link should be NVIDIA developer page for the Cuda toolkit. Now, if we click on this, we will be brought to this page here, and we will see a green download now button. If we click this, it will bring us to a page to install the Cuda toolkit. However, you may notice that this says 12.8, whereas our Nvidia SMI said 12.4. So we are going to want to make sure we download a matching version of the Cuda toolkit for what was listed in our Nvidia SMI. In our case, we just scroll down here and click on the archive of previous Cuda releases, which brings us to this page with a very large amount of Cuda releases. And if you were wondering, the first Cuda toolkit did come out in June of 2007. No, I'm just kidding. This is probably very dense, so I want to inject some form of like humor. But basically, we're just going to scroll down until we see Cuda toolkit 12.4.0 and click on this one. And once we are there, we almost basically have like a sort of decision tree thing to actually get to the correct commands to install this. So we will just kind of follow the decision tree. We are on Linux. We are on x86_64, which you are very likely on as well. And following that, we are going to click Ubuntu, as that is the distribution we are on. And we are on version 22.04. And another thing we need to select is the installer type. I just like doing local, so we are just going to click this. As we can see in the tooltip that pops up, it is a self-contained large file that only needs to be downloaded once and can be installed. So easy, simple, and works for us. Once we click that, we are going to basically see a bunch of commands right here, which you may think, hey, I can just copy paste these all and run them in at the same time. That won't work, and I know that from experience. So we basically need to run these sequentially, and without specifically kind of explaining exactly what each of these do, it basically downloads the installer, but also tells our system, hey, when you run this like apt-get command here, we're going to pin this version so you know to just go and install this version specifically and you don't accidentally go install some weird version. That's kind of the gist of what happens here. So we can just basically go ahead and start. And really, we're just going to sequentially copy paste these into the terminal as they run. Most of them won't take too long. There is one, I think, 3.5 GB download here, and we can see that we are once again prompted for our user password, being that that command had a sudo in front of it. And following that, we can just go ahead and run this one, which I do believe is the 3.5 GB download. So depending on network speed and things like that, this will take a little bit of time. It was 3.2 GB. I apologize. So we'll just kind of let that run. And once the installer has finished being downloaded to our system, we are just going to go ahead and run the following command, which won't take as long as the previous one did. And then we go ahead and just basically keep going. Following that, we are a bit familiar with this one right here, which is just basically kind of updating that catalog of our kind of available packages. Again, non-scientific, but you know. So the final thing to do here is to basically have the system install the Cuda toolkit version 12.4, which is what this will go ahead and do. And this will take a little bit of time. I don't actually know specifically how long, but a little bit seems a sufficient way to describe how long this will take. And again, this is like we're in Linux. It can be jarring at first when you're just getting used to seeing this amount of verbose text being thrown at you in rapid pace. So you get used to it over time. And once this is finished, we will just see done, which is awesome. And that means everything's successfully installed. So the next thing to do is basically just to check the version of NVIDIA Cuda Toolkit on your system, which you may recall could be done by nvcc-version. But when we run this, we are going to see that it does not actually show up. And this is really something that I think kind of, at this point, I see a lot of folks being like, I'm not going to deal with Linux, like this sucks. And I totally understand that, because this is where it gets perhaps a bit more frustrating and requires more kind of precise like control than Windows or Mac would. So imagine that our terminal here is kind of like a file cabinet where within that is a bunch of different locations of all of the packages and things like that we have installed on our system. even though we have now installed this or placed it in the file cabinet, our terminal doesn't actually know where in the file cabinet we placed it. So we basically need to kind of build that link so that our terminal knows automatically, oh yeah, NVIDIA Cuda Toolkit is right here in this drawer, like in this section. And that's referred to as adding this to our path. So what we are going to do here is, oh, not that, sorry, I messed up. You know what, actually that's good. If you accidentally type like a stray thing or something like that in the terminal and you don't know what to do, because like pressing enter can sometimes not like help you, you can always type Control-C, and that will kind of hopefully jump you out of like whatever mess up you have made like I had just done there. But back to the point. So basically the way I'm going to explain how to add this to path is by Google searching the issue, because we will see that there is a rather old kind of issue of the exact same type. So I am just going to type nvcc version Ubuntu path. And we will see one of the first things that pops up is an 8 or 9 year old kind of question here in Stack Exchange. And basically this individual is saying, okay, I installed this and I type nvcc -- version, but it says it's not installed. What do I do now? And this could really be extremely frustrating and cause you to tear your hair out. So, excuse me. Basically, the problem is we have not added it in the .bashrc file, which can be thought of as the kind of mapping to that file cabinet that our terminal has access to, metaphorically speaking. So the way to actually go ahead and do this is to export this to our path, which is basically running this. And if I type this right here, we will see, okay, I need to obviously change it to the Cuda version that we did use, which is 12.4. However, when I type enter here, if I then type nvcc -- version, we will see that Cuda Toolkit has been found, and now it seems like, oh, everything's all set. Not 100%. And again, this is kind of why Linux can be perhaps extremely frustrating to beginners, is because it somewhat kind of is not logical in this sense. I'm coming from like Windows or something. So if I open a new terminal window and type nvcc -- version again, we will see it's not found. And this is like time to chuck the computer out. However, the thing we need to do is kind of just understand a little about the back end of this, I suppose you could say. So this bashrc file here is basically kind of like the list that tells our terminal where that specific library is located within the file cabinet, if you will. If we just export it like that, this only persists within the actual terminal session that we write that in. So that's almost kind of like writing on a whiteboard with an erasable marker. Oh, it's right here. And then after this terminal window has been closed, that gets erased and it is not remembered by any other terminal window. So you will see if I run this again within the terminal window where we did export that, it will once again show up. But in the one where that had not been done, it has no idea where that is. So the way to do this, there really are two ways. The first is kind of what's listed here, where we could use Nano, which is an in-terminal text editor, to actually just kind of edit that file and append that line to the end of the file so that we can basically always have that. However, there is an easier way to do it, but unfortunately, I don't really fully remember what that way is. So what I'm going to do right now is really just show you kind of, this may seem sarcastic, but this will be a useful troubleshooting tip for dealing with any terminal errors or anything like that you may encounter. So we're just going to go to ChatGPT. I'm not even logged in. And I'm going to say, please give me the command to append this to my bashrc file. And it usually helps to kind of just say, so I said on Ubuntu, it'll understand, and basically it's going to give us something back that says echo and then does this. So basically this just kind of, instead of needing to go into the text editor and manually pasting this in, we can basically just run this, which will go ahead then and actually kind of just place it in that file already. So if we do that, we are all set, except we need to kind of reload that file that knows where everything is so that it persists across multiple different sessions and things like that. So to do that, we just type source ~/.bashrc, which we can do right here. And now once we have done that, we can basically go ahead and close both of those, open a new terminal window, and then type nvcc --version. And assuming everything has gone correctly, we will see that it is now recognized from within all of our terminal windows, meaning that the terminal is now correctly mapped to that folder within the file cabinet where the Cuda toolkit does exist. Again, this is non-technical, but just kind of having even a grasp that, oh, okay, sometimes you need to kind of do a few more steps beyond what you would think you need to do to actually get a piece of software recognized or installed on Ubuntu. It will help you very much. So it has come to my attention that we also, for best practice, should also do the following command here, which is the LD library path, which is like link dynamic or dynamic linker. It just also will help other things locate the Cuda toolkit. So remember, we can't just export it because then it will only persist through the current terminal session. So we actually need to run it with this echo. So basically, we are just going to kind of do a little like a, modification here. And if you do want to open a text editor here, you can just click text editor. And then from the applications menu, I apologize, I got distracted by a noise. And I will paste this command right here. And we are simply just going to change this to Cuda 12.4. And then following that, we need to actually make sure that we do the echo. So we are going to type echo in front of it and then put the entire thing in single quotes. One there and then one at the end. And then following that, we are going to need to basically make the system aware of where we want to actually append this, which will be in the bashrc file. So we will just paste that right here. And following that, we will basically just copy, paste into the terminal. And then following that, we will once again kind of reload the bashrc file so that the changes are kind of set in stone, I suppose you could say. And once we've done that, we are pretty much good with Nvidia Cuda toolkit. And I just think it's kind of cool to see how like these things are, I won't say old, but like, although it may seem odd at first sight, like this is kind of fundamental to some of the ways that like these OSs function and things like that. So, I mean, this was 8 years ago and it's still pretty much the exact same thing. We just changed the Cuda version. So that kind of stability is nice in the world of ever-changing OSs and things of that sort. But I digress. And now basically we are going to go ahead and then move on to actually setting up a Conda environment on this system. We are now going to go ahead and install Conda, which for the purpose of this video, we can kind of explain in a more simple and non-technical way. So if you have watched other videos of mine, or very likely anyone else who makes videos in this scope, you will likely be familiar with Conda and people creating Conda environments. For our purposes, let's imagine that we have an old video game that is version 1, but there were huge changes between version 1 and 2 of the video game, and we happen to like playing both of them. But if we were to simply try to install version 2 alongside version 1 on our system, it would just overwrite it because the game would need to be placed in the same exact location. A Conda environment would basically allow us to have a separate kind of containerized location for either of those installs, even if they were kind of like very similar or identical in a way that would otherwise kind of cause compatibility issues or overwrite existing files. So Conda basically allows us to have virtual environments in our system that contain within them the necessary packages for a specific program or something to run. And they allow us to have many slightly different or same versions of different dependencies, but without them actually like messing with one another. So oftentimes in some of the repositories that we will see that we want to run, they will basically have in the README, like one of the first things you do will be to create a Conda environment. So most recently, the Microsoft, like the not operator, but I forget what Omni parser. Like the first thing basically to do to install that is create a Conda environment. So it is something to know how to use, and fortunately it is really not as bad to install as Cuda Toolkit was, so we're going to jump right into it now. Basically, navigate to docs.anaconda.com, and from the page we are in right here, and I am going to make this a bit bigger, and then I will just shrink the terminal a bit. It normally won't be this obscene in size, but I made the font bigger so we could see. From this page, docs.anaconda.com, we are just basically going to go ahead and click on installing Anaconda. From there, we are going to scroll down, and we need to make sure we find Mini Conda because that's what we are actually looking at installing. So if we do see ourselves in the sidebar right here, we want to basically click on Mini Conda, as that is what we are actually going to be using. And when I say and show like Conda, it's actually this that I'm working with. So once we have correctly selected Mini Conda in the sidebar here, we are going to basically click on installing Mini Conda. And there are a few different ways to actually go ahead and do this. For my purposes and what I find easiest and what I personally do, the quick start install instructions tend to be sufficient and work quite well. So we just want to make sure that we actually select the operating system that we are using, which of course is Linux. And if we do so right here, we will basically see that somewhat similar to when we installed Cuda Toolkit, there are just a few different commands we need to run here. Fortunately, these are much easier, and we can basically go ahead and run them all at the same time, which is what we're going to do. So first we're going to copy paste the command right here, making sure that we are in the correct sub-selection here of the operating system. You're very likely not going to need to select either one of these, and if you do, you likely don't need to watch this video, but just make sure you're in the correct one. And once we've pasted this in, we press enter and allow it to kind of do its thing. Now, we will see that once it's done, we need to close and reopen our terminal or refresh it by running the following command. This is quite similar to what we did before, where we basically made the terminal aware that there is a new program and here's where it is. So we can actually visually see the differences here. As it currently sits, and I am going to kind of move this out of the way so we can focus more on the terminal, we see that when we open the terminal, we just have this kind of right here, and that's what we see every time we open a new terminal window. Once we run this, we are going to see that this changes slightly. So if we paste this in and press enter, we will see in parentheses now that it shows us next to this, which is what we were traditionally used to seeing, we see base. This basically tells us what Conda environment we are in, if any. So for the purpose of this video right here, we are not in a Conda environment. If we were to create a new Conda environment and then enter it, the text in here, base, would change to actually say the name of the Conda environment that we have created and switched into, which we are going to do, so we will actually see that in progress or in process. You know what I mean? So basically, it is quite simple, and this is kind of just the next thing we need to do. So to initialize it on all available shells, basically, we just run this. So between this and this, every time we actually open a new terminal, we can actually go ahead and see that base will be listed there in front of our regular prompt right here. And really, Conda is now installed and set up on our system to the point where our system knows that it's there, and we don't really have to worry about it not being found or anything like we did to the extent with Cuda Toolkit. Now, I think the thing to do here, because we are actually fairly close to wrapping up, which is exciting, is let's just make a new Conda environment just to actually test it and see how it works. So to make a Conda environment, we simply type Conda create -n space and then whatever you'd like to name your environment. So I'll just call it test. I know, very original. And then following that, we type Python equals and then a version. So we actually need to specify what version of Python we want to create this environment with. A lot of times the GitHub repositories that we want to run that tell us to make a Conda environment will also actually tell us what Python version to use. But for this demonstration, let's just use 3.10, which I like to use personally. Don't ask me why, but Once we do that, we can press enter and it will actually go ahead and create the environment. There is one additional thing, well, there's many, but one additional common thing we can do if we want to automatically say yes to the things it will ask us, which basically revolves around installing dependencies specific to like this Python environment we're making, we can type -y. However, right now I'm not going to do that. We are just going to run this as is, and basically we will see a few different things. If we had just appended -y, it wouldn't ask us what we see here. It would just automatically say yes and go ahead and install all of these kind of things. So we will type Y and press enter. And we can now see that we are still not in the environment because although we have created it, we still actually need to go ahead and activate it, which we can do by simply copy and pasting this. And once we press enter, we will see that base changes to test. And we are now in our Conda environment. So this is kind of our own little isolated space where we can install packages and things like that that won't interfere with other Conda environments or basically programs we try to run. If we want to exit out of a Conda environment, we do simply type Conda and then deactivate. You don't need to specify the name of the environment like you do when you activate it. It will just deactivate the current environment that you are in. And we can see it returns now to saying base. Now, really, there are obviously so much more topics that can be covered here, but in the interest of keeping this short enough that it's palatable and also just serving as kind of a beginner's guide, really hypothetically, we're all set now to go ahead and start installing and running some repositories from GitHub that may be Ubuntu/Nvidia specific. Our system is set up to actually go ahead and do that now, which is really quite cool and opens up a lot of possibilities in terms of exploratory and educational aspects. One thing I just kind of would like to quickly touch upon is hidden files in Ubuntu. Basically, there are certain files that are quote-unquote hidden, and for our purposes, what that means is that if we are actually browsing through the file explorer here, we won't actually see them, even though they may actually be located in this folder. So in order to actually show hidden files on this system, we will click the kind of 3 dashes right here in the file browser, and you simply just check the box here to show hidden files. And when we do that, we can't actually see like, oh, okay, I'm familiar with bashrc, this file right here, because if we scroll down, we can actually see that we have our mini Conda path here, which thankfully it automatically sets the Conda install to be in this file when we install it. But more familiar to us are the paths for our Cuda toolkit. So this is a hidden file, which basically just means that it's a file that exists but is not actually shown to us unless we specifically kind of want to see hidden files. You may sometimes need to mess with these or play with them. Oftentimes, if you download models from Hugging Face or you run a script that will automatically download the model for you from Hugging Face, it will be located in the hidden cache folder where there will be a Hugging Face folder in here, and very large model files may be located in there. This is probably something that doesn't need to be covered at this point, but just kind of as like the basis for future exploration, I suppose it's decent to bring that up. Really, we are on our kind of final step right now. The only other thing I want to do now is just kind of have us run a small, simple machine learning related GitHub repository to actually test our system and make sure that it works properly. And for that, I think we are just going to install Microsoft's Omni Parser, which you may have seen I did a video on Omni Parser and Omni Tool, which is the actual agent that can control the virtual machine. Omni Parser is just the part of it that actually kind of annotates the screenshots with bounding boxes and labels so that an agent can then use those to navigate around. So we are just going to search Microsoft Omni Parser, and something now that we may have not been able to do prior to actually getting this all set up is simply just following the README install instructions in this GitHub repository. So basically, let's jump right in and do it, because this is kind of a perfect example for our system to be tested with. We are going to begin by opening a terminal window, and perhaps I did make that font a little too big, but that's okay. So Sometimes it can get a little confusing with these repositories because it'll say first clone the repo and then install the environment. So if you just try to jump into actually doing this, typing cd and then omniparser is telling the system to change the directory we're in to the omniparser folder. This is truly akin to being in the file browser right here and telling the system to open the omniparser folder. Unfortunately, it does not currently exist, and this will give us the error here. And the reason for that is because we first need to actually clone it. So in order to clone something, we need to actually click the green code button in whatever GitHub repository we're going to be using. And we are actually going to just copy this HTTPS address right here and simply run git clone and then paste in the URL of the repository. However, when we do that for the first time on our system, we will see that Git is not found. So the system does not actually know like how to clone the repository using Git because Git does not exist on the system. Fortunately, kind of like with nvtop, it gives us the suggested command to actually install Git, which we can do. So we will just paste this in right here, which will then go ahead and install Git system-wide. So we don't have to worry about like any weird terminal behavior or the bash RC stuff. So we can type our password in right there. I was about to read the password out. And then once we do that, we will see that Git has been installed. So if I use the arrow keys to just navigate to the previously entered command so we don't have to enter it again, we can type git clone and then the URL of this repository, and it will go ahead and actually clone it into omniparser. I don't want to add confusion with this demonstration, but I do just kind of want to show that this is logically identical to just navigating around using the graphical file browser. So we can see that this has cloned into omniparser, which if we go into the file browser here, we can actually see that there is now an omniparser folder on our computer. So through the terminal, by running git clone, we actually like syntax or programmatically had this folder be created and all of the contents of this GitHub repository placed into it. So this is just a simple example of the kind of functionality of Ubuntu where we very commonly modify the file system by just typing things into the terminal as opposed to right-clicking, making a new folder, and then naming it. This can be much quicker and more efficient to actually do, but it is something to perhaps get used to a little. There are a few kind of commands that can help us here, but I also don't want to make things more confusing or verbose. If I type pwd, it's basically saying print working directory, which basically means what is the file path of the current location we're in. So right now, this terminal window is in /home/my username. Let's say that we wanted to go somewhere else and then clone the repository again to kind of see how this works. If we were to type cd, which stands for change directory, we could type in any one of these folder names here because those directories are located beneath the directory we're in right now. And again, I struggle as this is getting verbose, but just bear with me for like 2 minutes and hopefully it will make a little more sense. Let's say I type ls here. This is going to list all of the files contained within this folder, if you will, which is the exact same place that we are right here in the graphical file browser. So typing ls will basically show me all of the same items that I see when I navigate to my home folder graphically here. So basically, let's go ahead and just kind of close the graphical file browser for now, and let's go into the music folder. So if we type cd for change directory and then music, now keep in mind that Linux is very sensitive to capitalization. So if I were to type that with a lowercase m, it would say it does not exist. But if I type it with the correct capitalized M, as we can see exists right here, it will place us into that directory. And from there, we can see if we do pwd that we are now located within the music directory. So I know it's weird, but what we're going to do now will hopefully have it make a little more sense. So from within this terminal right now, we are in the music subdirectory of my home folder. If we were to actually, once again, run this git clone command and then paste it in here, this would actually go ahead and make the OmniParser folder from within the music folder and then put all the files in there. So we can actually visually see what we just did from my home folder here. If we click on music, we will see that there is now an OmniParser folder there as well. So that is just kind of a way to explain that we can modify the file system using just the terminal instead of where we may be used to just doing it like graphically through a file browser or something like that. I hope that makes some sense. I will just say, as you kind of play with it more and get used to it, it will become second nature and not something that perhaps has a learning curve anymore. Now, since we've done this, we do find that we are in the incorrect directory for what we need to do to actually follow along with this repository. So if we want to basically go to the previous folder, we can type cd space ... which just basically means it will put us in the folder like before the one we're in now. I will show you what I mean. So pwd says, okay, we're in the music folder, which is a subfolder of the kind of home folder of my system. If we type cd space ... and then we type pwd once more, we can see that that basically just shifted us up a level, so we are now just back into our home directory. I hope that wasn't too verbose, but we're basically just going to move on now to our first test of our system to see if it's all set up, which is to run the OmniParser repository. So we are just going to basically, from here, follow along with the install instructions. Being that we have already cloned it, we are just simply going to type cd OmniParser, which of course is going to change our current directory into the cloned OmniParser folder that we had done a while ago. Following that, we are going to create a new Conda environment named Omni, and it is going to use Python version 3.12. Now, we are not appending the -y to this command, so we will have to manually type y and press enter when it asks us if we would like to install all of these things. And once that's done, in following with the install instructions, we are simply going to activate this environment by just typing conda activate omni. And we can see that base has changed and we now see omni. So we are in the newly activated and created Conda environment. From there, we are going to type pip install -r requirements.txt. Basically, to make it simple, this is just going to install all of the Python dependencies that are necessary to actually run this repository. There is a bit more to it than that, but really it's kind of what that's doing. And you will see that this is a pretty common thing in these repositories because this is kind of a command that you can run to just automatically install everything that any one of these repositories would need to actually function. Some folks include these, some folks don't. There's many different ways, but for a lot of common ones, you will end up doing something akin to this. And it may take a little bit of time. As we can see, it's downloading like PyTorch and things of that sort, and NumPy, which you may have heard of, Ultralytics, OpenAI. You can see that a lot of the names of these actual like packages it's downloading are pretty familiar for like the AI sphere, if you will. And we can see that this is why it is a bit important to make sure you have a decent amount of space allocated for Ubuntu, because we have not even gone ahead and gotten to the point where we download the model files, and we've already downloaded multiple gigabytes of just dependencies for the actual project to run. And that is perhaps an inefficiency of kind of Conda and this ecosystem, is that for each of these projects we install, it will kind of reinstall the same thing multiple times, which can end up eating up a lot of space. There are kind of different methods to perhaps counter that, but for beginner friendliness, it's kind of just easier to get a bigger drive and just keep everything in its own environment. So once it has kind of finished downloading everything, it will basically just give you this huge list of everything it's installing, and that will take a little bit of time depending on what in fact it actually is installing. And this will be something that you quickly kind of get used to seeing and waiting for. But we let this finish, and then once it's done, we're pretty close to actually running our first test. which cool. We can see we now are. So we are simply just going to keep in following with the actual repository instructions here. So the next thing to do is just make sure we have the correct model weights installed. Basically, don't even worry as much about what we're doing right now, because the whole point of this is to just test that the system is set up correctly. So we're going to just run this command, which will basically just go ahead and download some model weights and things like that for OmniParser. And once that's done, our next step is really just to go ahead and run this Gradio demo, which basically will allow us to actually test OmniParser, which will take advantage of our graphics card and making sure that our system was set up accurately and correctly. So as we press enter there, we will see some things, but another thing we're going to want to do here is actually keep tabs on our graphics card and its memory utilization right now. So you may recall we could either do the Watch N1 Nvidia SMI, or we could use nvtop. Probably just better looking to use nvtop, which we will do right now. And being that my terminal font size is kind of set to an obscene amount, I apologize for that. But we can see that right now the graphics card is not quite doing anything yet, so just give it a little bit of time. But once this is kind of finished doing its thing, we will actually see a URL on our local host, which just means like 0.0.0.0. And then we will actually be able to click that and go in and use this OmniParser just real quick, which will then actually show us our memory utilization spike on our GPU and basically show us that our system is actually set up at some level of competency to be able to run some machine learning related tasks. So we can now see that as we get that URL right here, the graphics card utilization has spiked just a little bit. And when we actually click on this, so if you want to click on it, you can just click on it like that, but it might not work. So you want to hold Control and then click, and it will then open it in the browser. And now I'm actually just going to I'm going to minimize this because we don't need it. And we do see OmniParser is right here. Real quick, it basically will just take a screenshot of like a UI element and then output bounding boxes on it, as well as like labels and things like that, designed for agents to use to actually know where on the screen they should click. So I am going to just simply take a screenshot right here, which we can do if we just right click. Okay, that is incorrect. Right click in Firefox and then hit take screenshot. And I'm going to just save full page. I'm going to download it, and I will just kind of drag that to the desktop here so it's easy to drag into the interface. And once we have any image of a UI, you could just download a screenshot of something from Google. We will drag this in right here and then click submit. And really what we're more interested in is seeing the memory utilization on this card, which has already gone up a little bit from when we actually started this Gradio web interface. This will go up a bit more. And if this correctly outputs a like bounded image, we can see, okay, it jumped up to around like almost 2 gigabytes. And it did actually correctly output the image, which means that our graphics card actually is working. Nvidia Cuda Toolkit is set up. The graphics drivers are working, and we are actually at a point where we can take advantage of Ubuntu and Nvidia to actually run one of the cool, more experimental machine learning repositories, which was the whole point of this very probably long video. And we can see it correctly did this, but really, actually OmniParser is not the point of this video. It was just kind of a way to actually test that our graphics card was working properly. So that really is going to kind of conclude this video for the most part, because we basically now have a system that has maintained our original Windows installation. So we didn't really need to touch that at all, aside from just borrowing some space from the computer's hard drive to install Ubuntu. We then made sure that Ubuntu is booting alongside Windows. So when we start our machine up, we can choose whether to go to Ubuntu or Windows Boot Manager, which will just boot it into Windows 11. We have our Nvidia graphics card set up, both the drivers and the actual Cuda toolkit. We have the Cuda toolkit placed in our path, so basically the system knows where to find it when it needs to use it. We checked and made sure that we can actually run a repository that would not have worked at all if those things were incorrectly set up. We have Conda installed and set up so that we can pretty much follow a lot of instructions from GitHub, because a lot of them do use Conda still. And we basically have a functioning Ubuntu kind of machine learning / AI experimental machine in front of us, but we also have our original Windows installation. So this is kind of awesome, I think. And Ubuntu is definitely kind of scary to use at first and can be a bit intimidating, but really just the ability that it gives you to actually experience more and get more hands-on learning. And a lot of times repositories that look really cool will come out, but it will be for Ubuntu only and you'll need like Conda to run it. So this gives you the ability to actually play with those things as well. And I really have been wanting to do this because I know I make videos kind of showing how to install the repositories, but in those videos, it's basically starting from like here, which is already all set up. So I wanted to basically do a video where we actually show how to get to the point in which I start most of my videos. And that's pretty much what this is. I suppose to close it off, there are probably millions of things that I did not touch upon that could perhaps be pertinent to what we're doing here with Ubuntu and these cards and etc. But this gives us a solid foundation in which to actually further explore from and off. I do want to just quickly touch upon if you're facing issues. Well, obviously the ones we faced here, we kind of worked through together. Depending on your setup, there could be a number of other perhaps random issues. I would say first and foremost, secure boot can potentially cause issues with drivers, so make sure to check that. If your system is not giving you the option to boot into Ubuntu and is just going straight into Windows, check on your hard drive boot priority and things like that. You may also need to check to see if fast boot is enabled or disabled. But again, these are kind of like BIOS-centric things, which unfortunately are very kind of manufacturer specific. So mine, what we did here was for an MSI motherboard and their BIOS, but it may vary. Really, if you have issues where things are not being found, like NVCC is not located, even though you've installed it, just check your path in that bash RC file. And again, if having issues with like syntax or terminal errors, I would say 9 out of 10 times, and maybe even a higher percentage, if you copy paste those into ChatGPT or Claude or Gemini or whatever, and you say, I am on Ubuntu 2022.04, receiving this error, could you please assist me in troubleshooting it and fixing it? 95% of the time, they're going to properly guide you to the correct solution. It may be kind of a pain in the butt, but you'll get there. So that is really going to conclude this video, which may take me a while to edit, but yeah, I wanted to give a kind of beginner's guide to dual booting Ubuntu alongside Windows for machine learning / AI use cases. I hope this was helpful, and if you have any questions, definitely please feel free to leave them in the comments. If the questions are pertaining to like driver issues, just Google that, because I will have no idea. But no, I'm kind of kidding. So, all right, that's going to wrap it up. Thank you for watching, and I hope that this was useful.